Deepseek R1, the latest and greatest open source reasoning LLM, has taken the world by storm, and everyone is talking about its implications and its strengths and weaknesses. But what no one is really talking about is the kind of really powerful agentic workflows that it unlocks, and it needs more of a spotlight. So that is what I'm going to be doing in this video, showing you a super simple and really powerful agentic RAG setup with R1, and we're going to be using Smolagents by HuggingFace, a super simple agent framework to keep it very easy to understand and follow along. Plus, we're going to be doing everything locally with the R1 distill models. This agentic RAG setup centers around the fact that reasoning models like R1 are super powerful, but also quite slow. And because of that, there are a lot of people, myself included, that have started to experiment a little bit with combining the raw power of models like R1 with faster, more lightweight models that actually direct the conversation or agentic flow. You can basically think about it as these models having R1 as one of their tools, so that when necessary, they have access to more reasoning at the expense of a slower response. And for our use case in particular, what that means for us is we're going to have an R1-driven RAG tool that can be used to extract in-depth insights from a knowledge base while still keeping the rest of the conversation very, very nimble. And I've been using this to get some incredible results, even with the smaller distill R1 models. The example in this video is meant to be more of an introduction to these kind of agentic flows. That's why we keep it simple with small agents and a local knowledge base. But I am certainly planning on expanding this a lot more soon, creating a way more robust but still similar flow with Pydantic AI and LangGraph. So definitely let me know in the comments if you're interested in that. I have some wild ideas that I would absolutely love to build out and share with you. But anyway, enough of that. Let's get into this implementation with R1 and small agents. So I wanted to start by showing you this diagram here so you can conceptualize what we're building with Agentic RAG and R1 at a very high level. And again, this is going to be pretty simple here because I want to just introduce you to this huge rabbit hole that you can really go down with using reasoning LLMs, combining them with other LLMs in these kind of workflows. It's something that people are just not focusing on enough. So I really want to cover this with you, but also keep it concise and keep it simple. That's why we're going to be using small agents. So we have our primary LLM right here. I made this diagram with the help of Claude. So Claude called this fast agent. So this is an LLM like Llama or Qwen that is not a reasoning LLM. And because we are using small agents, they actually break down problems in steps. So you have this little bit of a loop here that I'll show you when we build out the workflow. So it thinks to itself a little bit, not as a reasoning LLM, just as a regular one. And then when it decides that it needs to look up knowledge, it'll call this tool right here. So this entire box that we see as the second bottom box, this is just a single tool for our primary LLM that is driving the conversation. And so it will have the user query passed in. It'll do a retrieval with RAG in our vector database to pull the relevant context to answer the user question, and then feed that into the reasoning LLM, which is R1 in this case, to extract the necessary insights from the context and then give it back to our primary agent to continue the conversation. And it might look a little complex here, but it's actually going to be very, very simple thanks to small agents, and also still very powerful thanks to R1. So here is the homepage for small agents, which is our ticket to bootstrap our agentic workflow with R1 very, very quickly. And they have very simple documentation to go along with a simple framework here. So if you click on the guided tour, from the homepage of small agents, this is the page I'd recommend reading through to get a solid understanding of the core of what small agents offers. They talk about installing it and how you can run it with any model that you would pick from HuggingFace just using their inference API. They talk about their code agent, their tool calling agent, and how you can set up your tools and create custom tools. Very, very simple. Nice and concise guide here. They got some examples as well, and then also some references here just so you can see all the parameters that you can use to set up your agents and tools, which we'll get into when we create our agentic flow as well. So absolutely wonderful. You just install this with pip, which I'll show later as well. And then the other thing that we want to install is Ollama, because this is one of the ways for us to run R1 locally. So you can just click on this download button right here just by going to ollama.com. And then when you search for models, like I can search for Deepseek R1 right here, we have all these different versions that are available for us to download and run locally. So the 671 billion parameter model. This is the massive version, the real version of Deepseek R1 that you couldn't really hope to actually run on your own hardware unless you're paying tens or hundreds of thousands of dollars, or you have a very small quantization, which I don't want to get into that in this video. But these other versions right here are quite small and realistic for anyone to run on their machine. So the 7 billion parameter version is what we're going to be running in this video here. And so what Deepseek actually did, it's super fascinating. They took their competitors, which are Qwen and Llama, and they essentially fine-tuned them based on data produced from Deepseek R1 to turn these into small reasoning LLMs that we can run locally very easily. So absolutely fascinating. That's what we're going to be doing later. I'll show you how to run this all with Ollama later as well. And then the other option that we have is we can install Deepseek directly from HuggingFace or use it through their inference endpoints here. And so I'll show later how to do that as well when we set up the code. But yeah, you can use HuggingFace or Ollama to get any version of Deepseek that you want, including the distill versions as well. Like if I wanted to install Qwen 2.5 14B, this version of R1. And so yeah, so many options for you. Now let's dive into getting things set up with small agents, and then I'll show you how to run all these models after that. All right, now it is time to create our agentic RAG system. So everything that I'm going to be going over here, all of the code that I've got right here in VS Code, I'll have in a GitHub repository, which I'll have a link to in the description of this video. So if there's anything that I didn't cover super clearly, you can also read through this README right here that you'll see there. So I make sure that it's super easy to set up and follow along with everything that we're building here. I also have a .env.example file to show you how to set up all the environment variables that you need. Also, this is able to work with both going through HuggingFace for your models and also going completely local with Ollama. So with that, let's dive into building out our agent. I'll walk through this with you step by step. We are building this from scratch here. So the first thing that I want to do is import all of the libraries that we need, most of which is going to be relying on small agents, all of these different classes that we have here for our agents, tools, and even our UI that we'll get to build up very, very quickly. Then we'll load our environment variables and grab the ID for our reasoning model like R1, or you could go use O3 Mini because apparently that was just released. I found out in the middle of recording this video. We're going to be using R1 for our reasoning model. And then the tool model ID, that's going to be the ID of our model that is going to be driving the primary conversation like Qwen or Llama, a non-reasoning LLM. And then we have our HuggingFace API token, which this is optional. There are a lot of models you can use for free through the HuggingFace API, but some are restricted, and then you get better rate limits if you just pay the $9 a month for HuggingFace Pro and get your API key. Then we're going to define a function to get our model, which there's going to be a different way that we do it based on if we're using HuggingFace or not. So that's determined through this environment variable right here. If we are using HuggingFace, then we're setting up an HF API model instance. So this is how we use the HuggingFace API to pull that model, like Llama 3.3 or Qwen or whatever it might be. And then if we are not using HuggingFace, i.e. we are using Ollama, then we're going to take advantage of the fact that Ollama is OpenAI API compatible. So we set up an OpenAI server model, but we're changing the base URL to just point to Ollama that is hosted locally on our computer. So as long as you went to ollama.com and installed it and you're running it on your computer, this will point to your Ollama instance. And then the API key, you can set this to whatever you want because we don't actually need a key when we're using Ollama locally. So that's how we get our model. Now we can actually use that to create our agent. So first of all, I want to create my reasoning model because this is what I'm going to use in my RAG tool. So I get the model based on the ID. This is going to be either the ID from HuggingFace or Ollama. And then I create an instance of the code agent. So in small agents, the base agent actually executes its actions through code. It's a very unique paradigm. I kind of have mixed feelings about this because sometimes I don't want my agents to execute their actions through code, but this is how you set up a base agent in small agents, so we're just going to roll with this. And obviously this LLM doesn't need any tools at all because it's just going to simply reason about the context given from a vector database using our reasoning model. And then I don't want to add any extra tools. There's a lot of base tools like web search that you can inject right into your small agent agents, which is super cool. But I don't want any of that for my reasoner here. And then also, like I said when I showed the diagram, you can actually have the small agents break up their problems step by step and kind of go in a little bit of a feedback loop. So I'm saying right here for my reasoner, I want it to have max steps of 2. So it's going to only reason back to itself one extra time, because I've seen it kind of hallucinate when it starts to get into a loop of doing it 6 or 7 times if you don't limit it right here. So that's a super important thing that I noticed from my testing. So that is our reasoning model. Now we want to get into our RAG tool. So the first thing that we need is an embedding model, because we have to take the user query and embed it and then match it against relevant context in the vector database, which, by the way, I'll show later how to set up the knowledge base as well. I just wanted to get our agent up and running first. So we create this embedding model from HuggingFace. So we're going to just be running this locally on our machine. And then we're going to get an instance of our vector database. Again, I'll show how to set this up later as well. And so now that we have our embedding model and we have our vector database instance, now we can define our tool. And this is going to look very similar to setting up your tools in another framework like LangChain or Pydantic AI. You use this tool decorator that we imported right here from Smolagents to tell our LLM that this is a tool that it has in its tool belt. And so I'm calling this RAG with reasoner because it's taking the context from the vector database and using R1 to get insights from it. And the parameter here is simply the user query. So what we want to actually search the vector database with. And so again, just like with LangChain and Pydantic AI and other frameworks, we use this docstring right here, this comment at the start of the function, to tell the LLM when and how to use this tool specifically. So we describe the tool and then also give the argument that it needs to provide whenever it calls this tool, because it has to pass in the user query. And so first of all, we're going to use our vector database to do a similarity search with our user query. And we're returning the top 3 relevant chunks of information that we stored in our knowledge base. And then we're going to just create a nice formatted string here to feed into the LLM, which this is not going back to our faster LLM right away. We are going to be putting it into R1 to extract the insights. And so this is the prompt that we're going to be feeding into R1, essentially just giving it the context and the user's question and getting the answer back. And we're even adding in a little bit here, saying that if there isn't sufficient information, we can actually return back to our primary LLM a better query for it to go through this loop, because we have that with Smolagents, to then try again with a better query for RAG. So we're already getting some kind of out-of-the-box power here that's more than just simple one-shot RAG. It's really agentic RAG because R1 is able to work with this other model and even tell it how to give better queries to actually search the vector database better. So it's really cool how even with something simple like this, we're starting to see a little bit of power, and you could easily see how you could extend this to do so much more to make a really, really robust agentic RAG setup. And so we just call our reasoner like this. With Smolagents, it's so easy. It's our model.run, we give it the prompt, and then we're saying reset equals false, because this is how we keep the conversation history going so that it can continue to reason not only about this current prompt that was sent into it, but also previous prompts and what it retrieved from the vector database earlier on as well. And then we just return the response to our primary LLM. Which, by the way, that is what we're setting up right here. So our tool model, as in our primary LLM, we get the model and then we create a tool calling agent. Everything looks very similar as before. We're not passing in extra tools. It is allowed 3 steps right here. And then for the tools, it's just an array with a single item, because right now, to keep it simple for agentic RAG, we just have a single tool right here to use the RAG with reasoner. And that is it. That is all it takes to create that entire workflow that I showed you the diagram for you earlier. And now to create the user interface with Smolagents, it is a single line of code because they are integrated directly with Gradio UI, so that with this single line right here, we can invoke the primary agent. And this is automatically going to actually apply the let me go back to this right here. Yeah, so it automatically applies reset equals false to the primary agent so that we have full conversation history within the UI as well. And then we just do .launch. That's it. We already have a UI. So now we are good to go. We have our agent set up. Now I just want to really quickly show you how to create our knowledge base and get our LLMs downloaded locally, and then we'll test it out. So we just finished making our main agent using a knowledge base that we didn't actually have set up yet. So I want to do that first because that's the the meat of what we're building here, but I still want to show you my process here for getting our local knowledge base set up with Chroma DB. So I'm keeping it super simple with this local knowledge base that every time I run this script to load all these PDFs from my data directory right here, it actually deletes the vector database entirely and then creates it again and reloads these PDFs. So just keeping it very, very simple. You can add your own PDFs into this data directory if you want, or just use these that I'll have in the GitHub repo as an example. It's just fake data that's generated from Claude. But anyway, we use LangChain here to load all these PDFs and then split them into chunks like you typically do with RAG. I didn't think too hard about how I was splitting or anything, just again, basic example. And then we have our function right here to clear the vector database, and then using the exact same embedding model that we used in our agent, we're creating embeddings for all of our chunks and then putting it into our Chroma database. And so you can run this as many times as you want, because it is going to clear the vector database each time before it inserts all the PDFs, so you're never going to have any duplicate data. And so once you have all this set up and your PDFs in the data folder, all you have to do is go into a terminal with this directory right here, and then run the command python ingest pdfs.py. It's going to be super quick because it's all just running a local vector database, and it'll get all that knowledge set up for you that's going to be leveraged in the agent that we just built. So the last thing to do before we run our agent is get Ollama and the models set up. So I have instructions in the README for how to do that. This is actually a super important tip because Ollama models by default only have 2,048 tokens for their context limit, which is super limiting. It's not enough for most use cases. And so these instructions actually show you how to turn your Ollama models into a version that has a larger context limit, like 8,096 tokens, for example, which is much more fitting for most local LLMs and most use cases. And you can even jack this number up to something like 32,000 as well if you are running a larger local LLM that can support that many tokens in a prompt. And so yeah, follow these instructions. Basically, you go into the Ollama models folder right here, and I have some of these already created for you as examples, or you can build your own model file. It's just 2 lines. It's super simple for whatever LLM that you want. So you call this file whatever, it doesn't actually matter. This is just for your reference. And then the first line it's from, and then the ID of the model that you get from Ollama. Like if I want to use Deepseek R1 7B, I'd copy this ID and then paste that in right here. And then the second line, you define the number of tokens that you want for the context limit now. So 8,096 would just be my recommendation for these models that we are running, because I want to be running 7 billion parameter version of Deepseek R1 distill, and then 7 billion parameter of Qwen instruct for my primary LLM that is not a reasoning LLM. So these 2 examples are already here for you. And then going back to the README, you just copy one of these commands, like I can copy this one right here. And then you go into your terminal where you have this current directory loaded up, and then I'll just paste in this command. And it's super simple. And if you don't have the model already from Ollama, it's going to download it for you right here and then create your version based on the model file. And then if you have the model already downloaded, it's not like it has to create another copy of it. So if your model is 10 gigabytes, it's not like it takes another 10 gigabytes to have this version of it. It's going to just use the exact same model that was already downloaded and then just add the configuration on top of it. So you don't have to worry about it taking more space on your hard drive or anything. And now you have a version of the model. Like I can literally call Deepseek R1 7B8K as one of my Ollama models now. And if I do an Ollama list, you'll even see that here as one of the models that I have available. And so it's just like any other Ollama model now. So we have that all set up. Now we can go into the environment variables and set these Ollama models for our reasoning model IDs and tool model IDs. Like I just go and I copy, let's just say this one right here. Well, actually, I'll do the 7 billion parameter one, and then I paste that in as my tool model ID. And then I just do the same setup for R1 7B and paste that here. And that's actually the 2 models that I'm going to be using for this demo, which we'll see right now. So I can actually show you my .env file in this example because we are running everything locally. So I have no API keys. I deleted my HuggingFace API token. I obviously tested that because I showed you that in the code as well. But right now we are just using Ollama. So I have the 7 billion parameter version of Distill R1, and then the 7 billion parameter version as well of Qwen 2.5 instruct. So tiny models that still work really well with this setup, especially because we have all the reasoning power of R1. And then obviously increasing the context limits like I just showed you how to do, because otherwise no matter the Ollama LLM, we get a lot of hallucinations. And so with that, I'll go over to my terminal here and then run the command python and then let's see, R1 small agent rag.py. So this is going to be using Gradio UI, which integrates right with small agents as I showed you, to pull up our front end in just seconds. And so it'll just be running locally right here. This is an old instance that I had running. So in a couple of seconds, once it loads up the site, I can just refresh and then we'll have a blank slate right here, a new conversation with our agent. And so because this is doing competitor analysis with all that fake data that I had in the PDFs in my data folder, I'm just going to ask it this question right here. Compare and contrast the services offered by a couple of the companies in my Chroma DB knowledge base. This will immediately start the prompt right here with our primary conversation driver, Qwen 2.57b instruct, and right away it decides to use our RAG with Reasoner tool, which is perfect. Passes in the user question as the argument here, and then all this context is what we are giving. This is what we fetch from the vector database. We give that to Deepseek R1 to reason with and give us the final insights. And something kind of weird that I see with small agents a lot is it fails to parse the thinking tokens from these reasoning LLMs. So you'll get this error here that you can actually ignore, and it's kind of neat that you can really see all the thinking tokens. It actually works out. It's kind of weird though. There's a lot of quirks with small agents that make me not like it a ton. That's also why I want to do a more robust implementation with Pydantic AI and LangGraph. But anyway, it still works. And so we give the final answer back. We have all the thinking tokens here and what it decided to give as a final answer back to our primary LLM, which then gives us the final answer here in the UI. So look at this. It even shows us in Gradio UI the different steps that it took and the parameters for function calls and execution logs and everything. It's so cool. Then we got the final answer here. And look at that. This is so good. And if we didn't get the right answer, R1 would have actually told Qwen to go back and use this tool again. And I see that a lot in my testing too. So it's very much Agentic RAG where it reasons with itself. And it's also Agentic RAG just because we're using an entirely separate LLM to handle the RAG results as well. So just absolutely fantastic in so many ways that you can expand this as well. Just the whole idea of using R1 and other reasoning models like O3 Mini now, along with faster LLMs in a workflow, it's just so powerful. It's something that's really worth wrapping your head around. So there you have it, a super simple and effective Agentic RAG setup with R1. And I really hope that this opens up the floodgates of ideas for you and all the ways that you could expand this simple use case here. And that's what I'm going to be doing on my channel pretty soon here as well. So definitely let me know if you're interested in that Pydantic AI and LangGraph implementation. I've got so many ideas around this and it's going to be a big project, but I'm pretty motivated to get it done, especially if I hear from you. So if you appreciated this content and you're looking forward to more things AI agents and reasoning LLMs, I would really appreciate a like and a subscribe. And with that, I will see you in the next video.